Hey, hello everyone. Welcome back to the channel. This is Praveen here. Now, as we have already started week 2 and in week 2 of free 30 days DevOps and SRE course, you all are able to see this is my YouTube channel where the week 2 first video was released yesterday, where I have discussed very important concepts, the projects, the roadmaps for week 2, right? And week 1, you can easily see here what are the videos I have already covered as part of your week 1, and there was a mega project in the live section. So many of you have commented that Praveen, where is the free mega project of day 6? So it will be in your live section, so definitely check out this. Now coming back on to your week 2, this is your day, I would say like day 7 of your video, where you will understand what is your AWS architectural components you need to have. At the same time, when someone is asking you in the interview about some of the components of AWS, you will be able to answer quickly with this video. And you can also have this as your system design round, and you can brush up your architectural overall holistic view of the architecture design in AWS, right? So this architecture is very generic for all the applications. So I have taken here the 3-tier application. So basically you will have a front end, you will have a business layer, and then you will have a DB layer, right? And various components of your AWS here we are going to see. So let's get started onto the video, and the like target for this video will be 100 because I am recording at 10:54 p.m. and I will be probably uploading in another 20 to 25 minutes for this day 7, right? So let's go ahead and see like what exactly it's stored for you. I've removed the slides because I don't have much time to cover, right? So let's go ahead. So basically, as I've told you, AWS is very, very vast. And in this video, we are going to discuss about various components of AWS on an architectural view. So stay tuned, like the video if you're liking the content, and share the channel link with your friends. So each of the content each of the component as I go ahead, right, I'll be describing about that. And don't worry if you're not able to see this small things on the video, everything I will be spelling out, right, whatever I am doing. So guys, let's start this video. So this is you, and this is me, and this is our friends, right? Anyone who is trying to access my AWS hosted resources, how the traffic management is, what are the components in my architecture, it should be present, everything I have covered here. So let's understand that whenever you hit, let's take www.praveensingampalli.com. This is my name and my website, basically praveensingampalli.com. What happens on the backend, how my website is architected on the backend, so I will be sharing with you all. So once you hit www.praveensingampalli.com, there are two things happening here. And if you see, okay, let me clear the screen and I will write it in a proper way. www.praveensingampalli.com, right? So here two things are happening on the simultaneous way. One is the request is going on the upward side, request is going on the downward side. So it's just a naming convention, but here two things are happening. So basically, if you are seeing there is a Cloudfront and there is a Route 53, both are the components of your AWS. And what each of the component is doing, let me explain you in a detailed way. Route 53 is basically your domain name system, DNS of AWS. So what is DNS will do? DNS will help me in finding the IP address. So basically it will map the URL with your IP address onto the system. Now, because all the EC2 instances, all the Kubernetes pods, everything comes up with your IP address. So this Route 53 helps in this pattern of matching. At the same time, it will help in URL to URL mapping. Let's take, I have www.praveensingampalli.com and I have to redirect it to some load balancer. I can do it, right? So URL to internal service components routing you can do. Third, you can have the routing. So Route 53 is basically routing to various components, right? You can have URL to IP mapping, URL to URL mapping. The third one is URL to your maybe you can say like any other service, may it be your Kubernetes, may it be or your EC2 instance, anything, right? And the fourth component is different types of routing it has. So the first type of routing you will see is geographical based routing, geo based routing. There are three to four types of routing. Geo based routing, you have latency based routing, and you have round robin based routing, right? And one more routing is there. I'm not remembering. So basically geo-based routing is your location-based routing. If your users are more in Mumbai region, you add your Route 53 in that particular region. Latency-based routing, you want to have your customers, given the low latency, you have your latency-based routing. It means the request will be served from the nearest location to the customers. Round robin based routing, so you can distribute like weighted what you call, like, let's say weighted distribution, right? So you can have, let's take like 70-30% of routing to any of the regions you can do, right? So I hope I am making it sense. So I'm a little bit skeptical about this. You can search. This is the standard data, you will get it. Now once the Route 53 is completed, let me clear the screen for you. Okay, what are the next things? You see Cloudfront. Cloudfront is basically, guys, you all have heard about the static data, right? Static data in the sense, let's take your Flipkart application. What will be your static data here? Your images, your videos, these all things, your phone videos, your images, all these things which you are able to see on the website is static, right? So in order to render this, so basically this was my Paytm question, a Paytm interview question, where he has asked, like, your app is taking more time to upload or download the photos or show the various kinds of products on the website. So you all have remembered, when you open an app, there will be like flickering of the images, right? So it will be like loading. So why that is happening? Because you don't have any caching mechanism. So CACHING caching mechanism is basically which is done with the AWS with the help of Cloudfront. Cloudfront is basically caching the static data. So you are seeing here, I have written something like your static data. And guys, this static data is two-way. It is given to the S3 bucket. Basically, it is stored in the S3 bucket and it is rendered from the S3 bucket, right? So static data caching, why we do caching? To increase, suppose I have 1, 2, 3 number in my S3 bucket. Let's take, I have a file in the S3 bucket which has 1, 2, 3 number, and my user here is trying to access this S3 bucket. He will access via the Cloudfront in the middle layer. Now, in the first time, the Cloudfront is not having the data, so it will hit the S3 bucket, get the data. Second time, the Cloudfront will have the cache. It will take the data and it will serve to the customer. So basically, for the caching mechanism, you will have this. So I will write here, for the routing purpose, you use Route 53. For the caching purpose, you use Cloudfront. Now, once these both things are happen, now let's go inside this. Now, this dashed line is your, let's take, is your AWS, right? And this is your VPC, right? So you can see here, AWS region 1, this is, and there are 2 regions, region 2. Right. So we are probably routing to both the regions. So basically this is DR compliant, disaster recovery. Suppose one region is down, my request will be going to the other region, right? So basically DR compliance, right? Disaster recovery compliance. Now we will be focusing on the region 1 big overview architecture, how the data is transferred. Now, once you receive the data here to the Route 53, the data is gone in. And basically, if you see, this is your internet gateway, which is your primary, you can say, like the talking person between your VPC and your internet. So once the request comes into your internet gateway, so where it is getting transferred, so we have this structure of under VPC, you have 2 availability zones. Under one VPC, you have 2 availability zone, right? Availability zones are basically for making sure you have more scalability, more reliability, more you have the flexibility to do the things. So you see availability zone 1 and availability zone 2, right? Availability zone 2 and availability zone 1 under the same region, right? Region of VPC. Right. So you see this, your orange dashed lines is basically region 2 and this is your region 1. Now don't get confused. Now let's follow only the blue lines. Imagine in the blue lines, like where it is flowing. Now, once the request is coming, it is sending the traffic to 2 places under both the regions. Now you see, this is your elastic load balancer, right? And this is your elastic load balancer for availability zone 2, availability zone 1, elastic load balancer. So how many public subnets we have, guys? The availability zone is divided into, again, 3 components. See here, public subnet, one public subnet, and the second one is your private subnet, right? And the third one is your private subnet. And the fourth one is again your private subnet. So how many components are there in my availability zone? In my availability zone, 1 public subnet and 3 private subnets, right? So what is the public subnet? What is a private subnet? Let me tell you in a small time. But let me clear the screen because you will get a little bit confusion because of this. Now, once we cover all these things, let's see like what is the next steps. Now, this is basically your load balancer, guys. Load balancer is balancing the load of the incoming requests, right? So both the regions, we have the load balancer. And once the load balancer receives the request, it will send to target groups. Now, these are your target groups. The load balancer is always kept in the public subnet, right? Public subnet in the sense directly interacting with your internet. The public subnet components will be directly interacting with your internet. Now, what is private subnet? Private subnet, which is not having interaction with your internet, right? So do you see any blue line here? No, right? It is not seen, right? It is not seen. So basically, this is your private subnet, which is not talking with your internet directly. This is your public subnet. And one more difference is, suppose you have a server here. How the server will talk to the internet is basically with the NAT gateway. Okay. So NAT gateway is always present in your public subnets. Now, very simple. I will tell you, this is your public subnet. This is your private subnet. Your private subnets are not given access to your internet gateway, right? It will talk with the internet with the help of your you can say like NAT gateway, network access translation, and then the request will come to the internet and any patching will help us. Why we need private subnet? Because you want to protect your databases, your applications, your important things, right? Similarly, your phone, right? You don't want to give direct access to anyone. You have the password, securities, everything, right? So we have talked about NAT gateway, which helps us in routing the traffic to the private subnet. And again, from the private subnet to the internet gateway, your load balancer basically balances the load. And you are able to see there is something like knuckles. Wherever you see something like your lock symbol, this is basically related to your security. So you see here dashed lines. This is your security group of load balancer. This is knuckles. Knuckles are basically network access control list and security group. People will ask generally the difference. I will tell you, network access control list is at subnet level, right? So if you are seeing this is at subnet level, so at subnet level, and if you see the security group is at service of AWS level, let's take ELB, EC2, right? All those things. Knuckles will have both allow policy and deny policy. It means because we are at subnet, I can deny my IP address coming from your home, 10.111.10. maybe 32 slash something. I want to deny means I can add it in the deny policy of Knuckles. Security group is basically allow inbound and outbound. Right? There is no deny, right? And security groups, right? So these are some basic differences. Now you see there is basically load balancer, which is kept in public subnet. Now let's see like what are the additional components you have, and very, very much important because this is going to be the big picture of your architecture. Now, once you get your request here, this load balancer redirects the request to your target groups, which are basically your web tier, web application web tier. Now in your web tier, you are able to see there are many web servers. So what are web servers? Basically, web servers are nothing but which takes the incoming traffic directly from your browser, right? So here you saw there is one component called Route 53, Cloudfront, then your internet gateway, then your public subnet, then your private subnet. Under the private subnet, there is web servers. The web servers take the data, and you already see here there is a auto scaling group to the web tier, whereas here load balancer is only there. Now, what is auto scaling group? Auto scaling group basically scales the instances, scales up and scales down. Basically, in your mem, if you have seen, there is one person, I think Thanos or someone, or Marvel or Avengers one, right? I posted on YouTube. You can see. I have posted on LinkedIn also. You can see. So basically, scales up and scales down. Basically, a cloud engineer, I think, right? So this auto scaling group helps our instances to scale up and scale down based on this load, right? So once this is done, you see there is something like router here. This is your router, which helps in managing the entire traffic of your availability zone, right? And once the traffic comes from the web server, there is one more load balancer which sends to the app server. Now, beyond the app server, there is one more load balancer. Beyond the web server, there is a load balancer. So load balancers always balances the load, right? And with the load balancer only. So the architecture will be like this: auto scaling group. Beyond that load balancer takes the traffic, auto scaling group manages the distribution of the instances, number of instances it will maintain, right? So you see here, this is there, Knuckles again there. Now there is a security group, database tier. So there are 4 subnets we have created, 2 public subnet. Okay, sorry, there are 4 subnets we have created, 1 public subnet and 3 private subnets, 1 private subnet, 2 private subnet and 3 private subnet. And everything is based on your architecture only. The 3rd private subnet, so basically 3-tier application we were designing. This is your web tier, this is your app tier, and this is your database tier, right? And this is your load balancing. Maybe you can say like some kind of tier, external tier, right? You see now, very important concept, the database is here. Let me clear the screen. Now, suppose I hit www.praveen.singampalli.com, right? Now, what will happen? The user comes here, the request comes here, the request comes here, the request comes here. From the internet gateway, it goes here, it goes here, it goes here. From the UI, so basically web server is basically, you can understand like your some server which redirects the traffic. You can consider like your, maybe you can consider like your maybe just your Apache. You can consider like your Apache HTTPD or Nginx, right? Nginx. So once this is coming here, you have the load balancer. The load balancer redirects the traffic to the app server. Your app server will basically have your Java-based application, your Node-based application, your Python-based application, and that application sends the data to the database, right? Suppose you hit www.praveensingampalli.com/courses, right? How the courses traverse here, 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 and from the DB, it again backs to the customer, right? So you see, there is a private subnet. Again, Knuckles introduced the security group to the DB is also there. Relational database system, RDS, master and read replica. So there is always a concept in the database. You have your, you can call like replicas and your master. So basically master is the one which takes the continuous data and the replica is one which gets synchronized parallelly, right? So replica is just to make sure you have high availability. Whenever we talk about cloud, I told you some 5 pointers: high availability, scaling, your reliability, cost, and security, right? So these 5 things are very much important when you talk in terms of your cloud. Now let's see like how the data is getting synchronized between the 2 availability zones, because you might get doubt when the request is coming here, coming here, coming here, and it is going till here. Praveen, what will happen if sometime my request goes here, right? So that's where your database are always in synchronization, right? Data replication, synchronization, right? Very much important for your disaster recovery concept or your high availability concept. Now, you see, suppose this region is sending the data like this. Suppose my request is coming here, right? So what will happen? The same traversing will be done. Your web servers, let's take your Nginx, pods, or anything, your HTTPD server. Same will come here. The router is there, web server. Again, the database. Here you see RDS standby and replicas. So there is a standby server and replica server. So basically here is our master which manages everything here, right? And you see this is all public subnet, and this is your S3 bucket which we store the objects. For example, you have your HDFC bank, right? HDFC bank account. You go into the bank and you ask for last 6 months data transactions, right? So the data can be stored in the different types of your storage mechanisms. Now in S3, we have something like, under the S3, you have the Glacier or S3 infrequent access, any kind of bucket you can store it. Now DynamoDB, there is one more database in AWS. Basically, this is like your key value pair. Suppose you want to store some key value pair, you can use it. PowerShell console, SNS, simple notification service. Suppose the data is sent here. If my, suppose I will show you www.praveensingampalli.com. Suppose my user is logging in, right? My user is registering. Let's take /register I hit. /register. So with that /register, I am sending the name of the user like Praveen. He is a student, right? And he is enrolling for the course 3.0 or 4.0 and some details. Now this details as an object goes here, goes here, goes here, goes here, goes to the DB, and the user should get a SMS also, right? Or he should get a email also, right? So he will come here. It will send the email to the particular user and a notification, right? So we are using it. CloudFormation is basically a service in AWS which will help in creation of the infra and console, right? I hope you are making it sense. Now, Praveen, I am very good here. Now, what will happen if this point is having issue? then my region 2 will be serving the data. So anytime in AWS, you think of like 2 regions, 2 availability zones are a must. 1 public subnet, 3 private subnet, 1 public subnet, 1 private subnet, 2 public subnets, 2 private subnet. Anything, you can make the changes accordingly. I hope I am making it sense. If you have liked the video, like the video and stay tuned. Very, very much focused things are coming in the going ahead days. And yes, I have forgot to tell you, these are some components basically with your monitoring, because CloudWatch, this is very much important. CloudWatch watches all the instances, all the servers, all the services in your AWS, and basically you can create a rule in order to set some alarms, right? So alarm can be CPU utilization 95%, your memory utilization 85%, right? So those kind of things you can put it, and you can notify your auto scaling groups based on these rules, right? This is your auto scaling group. Now there is an AMI concept, which I have already told you. Amazon machine image, and all the servers are spinned up with this image only. That is why you see both the arrows. Now, I think I have covered most of the things, very, very much clear. Whenever a user is typing www.praveensingampalli.com, he will first hit the Route 53. Similarly, the data is sent to the Cloudfront. Now, once it comes here, there are 2 regions, region 1 and region 2. Now, I want to move to the region 2. There are 2 availability zones, availability zone 1, availability zone 2. Availability zone 1, the data goes in. It goes with the public subnet, then to the private subnet, which has the web tier, then to the app tier, then to the database tier. The database is always synchronized with your availability zone 2, and make sure your availability zone 2 is the replica of the availability zone 1. So that's how I remember the things, and I make sure you are very much confident about this. As we go ahead, we are getting so many good things coming in. Sorry for the delayed release of this video. Please do watch it. Even it's 11:15 p.m. now, IST, and I hope you will give a like to this video and subscribe to the channel if you are with me. Stay tuned. Many more things are coming up. This is Singham signing off.